Good afternoon, everyone. My name is Sonia, and our team did the electrical safety power flow. That was our goal for this hack. Our team included Raymond, who was not able to join us up here, but he was our lead programmer with the Beck group. We've got Mike Cross, Jordan Mansfield, Chris Miller, Tyler Murphy, and Leo Papart. And we joined efforts, electrical subcontractor, the Superior Group, and the White & Turner Company, GC. So it was great to work on the same side, as usual. As usual. So our problem, during construction it is important to know what electrical equipment is on and off, the status of it, as well as what that equipment feeds in order to safely complete the building. There's a lot of times where you go up to a panel and you're not 100% sure, you should be, and there's a whole lockout, tagout process that goes into that, but there is room for accidents, and it's always our goal to reduce those accidents as much as possible. So how can we efficiently compile this information and analyze it? So, you know, what panel feeds what, and how can we find the best way to organize that information for everyone to access. So the current solution is to scrutinize the drawings, take a look at the one-line diagrams and the panel schedules, and gather all that information together in either a power flow matrix, a feeder schedule, and then use that to create your lockout tagout plans. An example of what some of these look like. The power flow matrix, for us, one of our examples was you're taking from beginning to end that lineup. So you'll have over 1,000 rows of data. This is just showing approximately 120 of them, but I have a laser, but you can see that at the very beginning on the far left there's the main panel that feeds it, and then it breaks off into smaller and smaller panels, and then eventually the branch circuits. It's hours of data entry, hard to visualize, it's difficult to verify because there's a lot of manual entry, room for error, and it's constantly needs to be updated. So every time you get a new drawing issuance, you have to go through that process again. And those panel schedules on some projects, they change a lot. This is an example of a feeder schedule. We had to zoom out just to try and show just a portion of that information. There's so much that is captured, and this is more on the electrical side. So the subcontractor, they will put this together. They're doing the same scrutinizing of the information, going through it and redoing all the work that in some cases you might even have in the front end in the model. So our hack solutions, we mainly focused on trying to extract that data. So Revit was our main source. In some cases you'll get a very smart Revit model that has the panel schedules, that has some of that logic that connects all those different panels together, and that was the goal, is to take that information and make it useful. So our solution was either navigating that information with an Excel or a Google spreadsheet, so getting that information out of Revit or finding some other way to manipulate that data and finding a way to then take it into a format that we could use. The other option, which we also worked diligently on, was the mobile-friendly searchable web interface. This could then be taken to the next level using a QR code. You could then go up to the panel, you have these QR codes, and they get you to that web interface. The benefits for the general contractors, electricians, building maintenance, mechanical, there's so many different avenues. So if you're going down to the basic level of a RTU or some piece of equipment on the tail end of it, the mechanical equipment, you can see what's going on with it and be able to see, okay, if I want to turn this off and be able to work on it, where do I need to go? And with that, I will pass it on to Mike Cross.
All right, so the big thing was data extraction. How do we get this information? So ideally, you would have a Revit model that an engineer or designer already put all that information together. It already shows what's tied to what. That information is there, just how do we get it out of the model? Another thing is a lot of our guys who do a lot of this work might not be as familiar with the formulas you can do in even just Excel or a Google spreadsheet. So how do we make their lives a little easier so they're actually gathering less data? So again, if there is no Revit model or it's an incomplete model, everything's not linked together, we basically have to pore over the one-line drawings, really scrutinize all that data and find out what's directly feeding each piece of equipment. So one thing we thought of is if we already know what's directly upstream of each piece of equipment, we can use a formula, whether we use like an array or a list mixed with a match, to automatically just search a range and automatically get what's downstream of each one of those panels. We never quite exactly figured out how to mine that data, but we know those options are out there and it's just figuring out those formulas. So again, the ideal one that we spend a lot of time with, and thanks to Raymond we're able to get, is extract the Revit ODBC database information, utilize the ties that already exist in that database, and basically just combine the different information so you can pull out exactly what you need. So this is an example of when we pulled it out into SQL. So you can see on the left, again, kind of small so you can see everything, but on the left you have that tree and that's every single little database or information that Revit already pulls, and that was a pretty large list. So you can pull out rooms, electrical equipment, mechanical equipment, etc. So the next part is how do we search and analyze it? So this was an example of just something quick I put together in Google Spreadsheets. So if we already have that list of data, you can automatically just use like a drop down or a data validation to choose, if you have multiple projects, you would choose a project and then choose the piece of equipment that you want to look at and figure out, what's it feeding, what's it being fed by, maybe the room it's located in. All that information is there, you just need to be able to pull it out. And this was an example of kind of a power feed, so this kind of looks like a one-line diagram. So say, you don't have the drawings in front of you or the drawings are really big, it's hard to look at on a phone. You could just search for that specific piece of equipment and you only want to know what's directly above it, directly below it. Then you just punch in that piece of equipment and it'll show you that information automatically. And with that, I'll turn it over to Jordan.
All right, so kind of a continuation of the whole process here, what we've been talking about. One of the last pieces of the puzzle would be able to access that data from the field. And so, there's numerous people working on a job site. Information, to have that information readily available can really speed up a lot of processes and save time and money. So our idea was to place a QR code on each piece of equipment out in the field. And you'll be able to scan that with your phone with a simple QR code scanner. And that'll take you to that the interface that Mike was describing, where you can search that piece of equipment, that panel number, that item, and it'll tell you exactly what it's fed from and what it also feeds. So we realize with all of this that there are some potential failure points. This could help aid the next round of development with this. As Mike and Sonia both mentioned, the Revit model may be incomplete and not have all the relationships there that you need. So when you extract the data, it might not be as beneficial as you would like it to be. If you don't have internet access in the field while you're on the job, if you're on the construction site, we run into that issue a lot on our project. Just bad internet connection or a bad cellular connection. You might not have a smartphone or a phone that has a camera or scanner capabilities to scan those QR codes. Incorrect labels on equipments or drawings. That's a frequent mistake that happens quite often. So, and then also if items in the field weren't installed correctly to the plans or the specs as they should be, that would also create an issue. So some of the ideas we wanted to expand upon, just a quick run through here, and then I'll have the rest of the guys kind of speak about them in more detail. But have a power indicator kind of interface where you can see exactly what item, what piece of equipment has power, whether or not it's turned on or turned off. Have a procedure in place with a user interface that shows lockout, tagout, who locked out this piece of equipment or this panel, when and where and why. This could also have applications towards the commissioning side of things. If a piece of equipment or panel has been fully tested and commissioned. Facilities management also would be one application. How can we use this this information from the model to really help the end user. And then also just talking about some other data collection tools if we don't have a model. So with that, I'm going to hand it off to Chris.
Hi. So another really important aspect of this is making it easy for the end user to interact with. So we would like to have a search function as well as a visual representation of what the power status is. So here we can see green, everything's energized. And you go through and you can start seeing what happens when you start de-energizing stuff. Panel 1's off, the rest is off as well. Then you have a generator added in and it's not energized as it doesn't need to be. Then the main utility would go off and you'd be able to see that most of the power's off, but the generator kicks in. And yeah, that was it for that. So I'm going to hand it off to Leo.
Hey. All right, again, quick shout out to Raymond. He was a tremendous help to us. He should have been here to kind of give the presentation with us, and also our shy friend Tyler here, who's not going to talk, but want to make sure he's in there. So lockout, tagout, safety on the job sites, obviously a huge importance factor to that. Who locked the equipment out, contact information to that person, what was powered down, why was it powered down, how long is it going to be powered down. All those factors are huge, and they impact everybody on the job. So being able to identify what those are and having a system in place to easily retrieve that information. So the concept is everybody would have kind of like their own profile for the project to be able to interact with the system. They would be able to log in, all their credentials are already recorded, their lock numbers, who they work for, what their contact information is, so it's not something that anybody can really forget to do. If they walk up and they scan the information, and they can update the information to the specific equipment that they are locking out. And again, all that information would be already recorded from the beginning of the project or when they hit the site, so that way they don't have to spend a lot of time trying to enter data, or they're just rubber number type scenario where they're just putting information in to get to what they need to get to. So it kind of would follow the same process as far as equipment that is not energized or that hasn't been turned on yet or has been turned on yet, that they can go through and they can lock it out, and that visual representation of what is locked out, what's affected downstream, so that everybody's aware, and then also be able to tell who that person is so that we can make sure that we can get that back online if necessary. So the lockout, tag out, the safety process is definitely a huge application of this, as well as being able to track what is energized, what's not energized for other safety reasons as well. So commissioning, that you?
So like we were mentioning earlier, again, commissioning, there's a lot of testing and things need to get done in order to make sure that equipment's ready to be turned over, does it work properly, all that. So if we were able to link each piece of equipment with actually its own URL, so it would have its own QR code, you can sync up to that just by walking up to a piece of equipment and okay, I'm going to complete this, or I notice this is done, so I'm going to check it off. So you go up, scan it, check it off, it automatically brings you to its own code and it's done. And again, that's already linked to the power, any kind of other sign-offs, you got permits, any other information. And then this goes hand in hand, you can turn it over to the client, the end user, with their facilities management, so they can walk up, do the same thing, scan the code, and then they'd be able to see, when's the last time this got a new filter, when's the last time this had maintenance done, hey, this isn't working right, do I still have a warranty on it? You could also have maybe the installing contractor's information, all sorts of other information. If you really want to get fancy, all of us here pretty much work in BIM. You can link this up to Navisworks or Revit, so then even if they're just in the model, they already have the link that brings them to that equipment and all the information they need. Sonia.
So the other step, just in case you can't get all this information out of Revit, which granted has happened to all of us, we can't get the information we need sometimes. There's also another aspect that we briefly started looking into, but we definitely want to try and pursue a little more. So those single line diagrams, kind of like the examples we showed you, having a way to analyze those as well as the panel schedule and be able to take those relationships between the panels and make sense of it. So we have OCR, we have other text recognition softwares. The next step is finding ways to recognize relationships as well. Basically making a table again in another format, or a flowchart a flowchart. And then that fills in the blanks for the times that you can't get that information from Revit. You still can go back to the drawings and be more efficient with it. With that, we'll do a real quick demonstration of some of the output, and thank you to our hosts. Thank you to the sponsors, the presenters, and Addison Treehouse. Mike, do you want to scan that while I do?
Right, that's basically just a that's basically just a scanner. So if anyone, if you're watching this presentation online or anything, that'll bring you actually to the Google Drive page where we have all the information for everything we've worked on, including what Sonia's pulling up right now. So you can take a look at it, see what information you can gain from it or what you can utilize it for.
So this is very basic, very just the beginning of the process for us, but it's a basic web interface. You have your home, you log into this, and it has a search feature so you can find a panel. The QR code will bring you up to this, and then you can find whatever panel you happen to be standing in front of at that moment from there. Not quite a lefty. So then it tells you service A2 switchboard, that is the panel you're currently looking at, and from there what's feeding it, and here we are. So this is your 2. So from this panel to where we are now. So if I click from, that'll take me to the next step up. So the future of this is trying to get it into a flow chart so it's a little more user friendly, a little more visible, but let me try this one. So yes, then it takes you to service A1 switchboard. And the other step was being able to edit the status of it. So you can say, if it's unchecked, it's off. And you can come into this, edit it, change the status to on, update, and it will check everything that panel feeds down the line. So that way you know, okay, if I'm working on that rooftop unit down on the end, I've got power to it now, so I need to be careful. Versus if it's off, you can't turn that RTU unit on or the panel that feeds it if the one right above it is off. And that sums it up, so thanks for hearing us out.